is replacing or rewiring it. Okay, so accidentally he must not touch the contacts of the fuse to which supply is given. So you must be very careful while rewiring or replacing the fuse. So let us discuss low voltage fuses. So low voltage fuses can be further categorized into semi-enclosed revariable fuse, high rupturing capacity cartridge fuse, high rupturing capacity fuse with tripping device. So it can be, the low voltage fuses can be categorized into three types, that is semi-enclosed revariable fuse, Hrc cartridge fuse, Hrc fuse with tripping device. So let us discuss one by one in detail. The first one is semi-enclosed revariable fuse. You can even call it as KitKat type fuse. So this is it. This is a KitKat type fuse. So there is another image. So in this image we can see. So this fuse is the fuse carrier. And it also it consists of a fusing wire. We can even call it as fuse element. This fuse element is made up of tinned copper wire. What is tinned copper wire? We have already discussed in the earlier classes. In between these two terminals, a tinned copper wire is fixed, which is the fusing element. And this fuse carrier, after placing this tinned copper wire in between these two terminals, fuse carrier is inserted into the base. So under normal operating condition, where current is flowing through this fusing element, that is tinned copper wire, uh, the tinned copper wire will not get overheated. Of course, the temperature of the copper wire may increase, but it will not reach to its melting point. So when fault occurs, the fuse element is blown out. Means the melting point of this fusing element, the cotton or copper wire element is reached whenever fault occurs, whenever excessive current is there in the circuit in which this fuse is connected. So this just it reaches to its melting point and it just blows out and the circuit is interrupted. So fuse carrier is, as soon as circuit is interrupted, the fuse carrier is taken out from this base and the fusing element is replaced with the new one, and after replacing it with the new one, fuse carrier is reinserted into the base to restore the supply. So the detachable fuse carrier permits the replacement of fuse element without any danger of coming in contact with the live parts, and this cost of replacement is negligible, and this use of means the use of these fuses is limited to domestic loads as well as lighting loads because of low current interrupting capacity, so their usage is limited to only domestic purpose as well as lighting loads. Okay, next one is next type is high rupturing capacity cartridge fuse, HRC fuse. Okay, HRC fuse we can say, or HRC cartridge fuse. So you can see here, this is the cartridge fuse. Let us discuss its construction and operation in detail. So whatever limitations are there in the semi-re-enclosed KitKat type fuse. Those limitations are overcome by using this HRC cartridge fuse. The limitation is that one of the limitation is that it can interrupt only low voltages or low currents, and the breaking capacity of that KitKat type fusing element or the fuse is uncertain. Okay, because of low current interrupting capacity and because of uncertain breaking capacity of semi-re-enclosed revariable semi-enclosed revariable fuse, the HRC cartridge fuse is preferable. Okay, in order to overcome those limitations, HRC cartridge fuse is preferable when compared to that. So this HRC cartridge fuse consists of high resisting ceramic body having metal end caps. So these are the metal end caps. Okay, it is made up of a high resisting ceramic body, and it inside this ceramic body, the metal end caps are connected to a silver current carrying element. This red line, if you see, it is a silver current carrying element. You call this is nothing but the fusing element. Okay, so the spacing that is surrounding this silver current carrying element is filled with a filling powder. This filling powder, it can be a chalk powder or plaster of Paris, quartz or marble dust. The purpose of filling this filling powder in the spacing surrounding this fusing element is that this filling powder will quench the arc if arc is struck between the contacts, and it also acts as the cooling medium. So, under normal operating condition, this fuse element will be at its normal temperature. Okay, means it won't reach to its melting point. Hence, this fusing element will not break and it will not get overheated because it is because of the normal current. This fusing element will not will not get overheated, and hence its melting point is not reached. So whenever fault occurs, the excessive current will increase the temperature of this fusing element. It gets overheated and hence it melts. Okay. So in order to break this fusing element, bimetal thermal control is placed at the center of this fuse element so that it will help the fuse to immediately break the circuit, because as soon as fuse is melted, an arc is struck between these two terminals. Okay, so whenever this arc will continue the fault current to flow from one phase line to the other phase line. Okay, so we have to quench the arc as quickly as possible. We have to extinguish the arc as quickly as possible. Okay, so now, so because of the as soon as the fusing element melts, okay, so the silver material will be vaporized. This silver material which is vaporized, that is silver vapors, will have chemical reaction with the filling powder that will result in the formation of high resistance substance which helps in quenching the arc. So one thing that we must remember is, as soon as fuse is blown out, fuse melts, and there will be a continuity of fault current in between these two terminals because of the discharge of electrons from one terminal to another terminal. That discharge of electrons is nothing but the arc. Okay, so this arc is extinguished due to the chemical reaction of the silver vapors with the filling powder. Okay, and when due to the chemical reaction between these silver vapors and the chemical powders, a high resistance substance is formed which will extinguish the arc. Okay, so this is all about this HRC cartridge fuse, and next one is HRC fuse with tripping device. Okay, so we already know about the tripping device. Tripping device we know the operation of a circuit breaker. So circuit breaker will be consisting of a moving contact and fixed contact. The moving contact of the circuit breaker will be connected to the tripping device. Okay, so the tripping device is actually connected to the relay. So the relay is the one which senses the fault in the circuit. So whenever a relay senses the fault, okay, so excessive current will flow in the relay coil. Hence, trip circuit is closed. Whenever trip circuit is closed, the trip coil gets energized. Whenever trip coil gets energized, the moving contact of the circuit breaker will move away from the fixed contact. So the tripping device is the one which is causing the operation of the circuit breaker. Means the circuit breaker contacts will open because of the tripping device. Here also almost same procedure is applicable here. So this HRC fuse, of course, it will be having a fusing element, but if it fails to interrupt the fault, then the circuit breaker will operate. Okay, so this HRC fuse will be having tripping device. Okay, and it also has a plunger. Okay, you can see in this image. In this image, we can see this HRC fuse has a plunger here, and it has a weak link. This weak link chamber, it is filled with a chemical charge, and there is a tungsten wire connected here, and there are silver fuse elements here on both sides of the tungsten wire. So So when fuse blows out under fault conditions, the tripping devices will cause the circuit breaker to operate in this condition. Okay, so this is our HRC fuse with tripping device. So whenever fuse is blown out, the tripping device will cause the circuit breaker to operate. So let us discuss in detail. So the body of the fuse is of weak link ceramic material with a metallic cap rigidly fixed at each end. Okay, a metallic cap is fixed at both ends, at the lower end and at the upper end. Metallic cap is fixed. So um, these are connected to number of silver fuse elements. So there are these n number of means, of course here you can see only few number of silver fuse elements. They can be more than that. So at one end is a plunger which under fault condition hits the tripping mechanism of the circuit breaker and causes it to operate. The plunger is electrically connected through a fusible link, chemical charge, and a tungsten wire to the other end of the cap. Okay, so you can see here there is a plunger which is electrically connected through a fusible link, chemical charge, and tungsten wire to the other end of the cap. This is the other end of the cap. So when fault occurs, first of all, silver fuse elements are the first to be blown out, and then current is transferred to the tungsten wire. Fault current is transferred to the tungsten wire. The weak link in series with the tungsten wire gets fused and causes the chemical charge to be deteriorated. As soon as fault current is shifted to tungsten wire, this weak link will in series with this wire gets fused, okay, and causes chemical charges to detonated. Means they just explode. Okay, these chemical charges will explode, and this will force the plunger outward. Okay, so when plunger is pushed outward, what will happen is circuit breaker will operate. Okay, so this is a low voltage HRC fuse having breaking capacity of 16,000 amperes to 30,000 amperes at 440 volts. They are extensively used on low voltage distribution systems against overload and short circuit conditions. Okay, so this is about low voltage fuses. Next, high voltage fuses. So high voltage fuses can be categorized. One of the high voltage fuses, cartridge type HVHRC fuse. Other one is liquid type HVHRC fuse. Okay, so you can see here somewhere liquid type HRC fuse. Okay, So broadly they can be classified into two. So this cartridge type HRC fuse is its construction is almost similar to the cartridge type HRC fuse of your low voltage. Okay, so the low voltage fuse, a low voltage cartridge type HRC fuse and high voltage cartridge type HRC fuses constructions are almost similar, except that there is a special feature incorporated in this device, which is not shown here. I have shown the same image here for okay. So some designs employ fuse element wound in the form of helix. Okay, so you can see here fuse element. So it will be in the form of helix here. You can see a straight fuse element here, but it will be in the form of helix so as to avoid corona effect at higher voltages. Okay, so in order to avoid corona effect at higher voltages, this helical fusing element is provided. In some designs there will be two fuse elements in parallel. There will be two fuse elements here. You can see only one, but there will be two fuse elements, one of low resistance and other of high resistance. Okay, so the low resistance fusing element is silver wire and high resistance fusing element is tungsten wire. So and this cartridge type HRC fuse, it can have two fusing elements, one of low resistance, one of high resistance. Low resistance is made up of silver wire, high resistance is made up of tungsten wire. Under normal operating condition, this low resistance element will carry the normal current. When fault occurs, the low resistance element is blown out and high resistance element reduces the short circuit current and finally breaks the circuit. Okay, so under normal operating condition, no current will flow through the high resistance element. Only the current will flow only through the low resistance element. So whenever fault occurs, whenever the current in the circuit is excessive, what will happen is the low resistance element will immediately blow out because of the excessive current, and this high resistance element will reduce the short circuit current. It will try to reduce it, of course, but finally it breaks the circuit. The high voltage cartridge fuses are usually used up to 33 kilovolts with breaking capacity of about 8700 amperes at that voltage and rating of the order of 200 amperes at 66 kilovolts and 11 kilovolts and 50 amperes at 33 kilovolts are also available. Okay, so these are all the ratings of this. You can see here, this is the rating of the order. Okay. So next is liquid type HV HRC fuse. So I'm showing you two figures here. Okay. So this is the liquid type HV HRC fuse. So in these fuses have a widest range of applications at HV side, high voltage side. They are used for circuits up to 100 amperes rated current on system up to 132 kilovolts and may have breaking capacity of the order of 6100 amperes. So these liquid type fuse HVHRC fuses, they will be consisting of a glass tube filled with carbon tetrachloride solution. So it consists of a glass tube. So you can see the glass tube, that image I have here somewhere. Yeah. So this is it. This is the glass tube. Okay, I have one more image. You can see this is the glass tube. Okay. So this glass tube is filled with carbon tetrachloride solution and sealed at both ends with brass cap. Okay, both ends are sealed with brass cap. Okay, so within the glass tube, one end of the fuse wire is sealed to one end of the tube, and the other end of the fuse wire is held by a strong phosphor bronze spiral spring fixed at the other end of the glass tube. Okay, so this is the fusing element which is held in position by one end of the tube. Other end is held in position by the spring, strong phosphor bronze spiral spring. So when current exceeds the required limit or prescribed limit, so means whenever fault occurs, when current becomes excessive, then this fusing wire will melt. And what will happen as soon as fuse melts, an arc is struck between these two terminals. So there will be still means even though fuse has melted, there is continuity of discharge of electrons from the in between these two terminals. Okay, and the spring will retract part of it through a baffle, that is liquid detector. Okay, okay. So this is the liquid detector. This liquid detector will what happens is as soon as arc is struck here, the spring which was held in position because of the fuse wire, it just strings as soon as fuse is blown out, just strings. So what will happen is when it shrinks, what will happen? The liquid detector will push oil in between these two contacts. Okay, so when oil is pushed in between the contacts, already the because of the heat produced by the arc, this liquid the liquid gets vaporized. Some of the liquid gets vaporized surrounding the arc. These gases will uh, will be surrounding the arc, and these gases will act as the arc quenching medium, and the arc will be extinguished. Okay, so this is about the liquid type. So next, now one more type of fuse that is available in the market is metal clad type fuse. So you can see here, this is a metal clad type fuse. And metal clad oil immersed fuse. This is an metal clad oil immersed fuse, which has been developed with the object of providing substitute for the oil circuit breakers. Okay. So in order to means these fuses were developed to replace the oil circuit breakers. And these fuses can be used for very high voltage circuits and operate more satisfactorily under short circuit conditions, approaching their rated capacity. Actually, this topic is not required as per your syllabus, but I thought it will be useful to you to know about this fuse also. So the rated voltage levels of the metal clad fuses are of 5 kilovolts and 38 kilovolts. And next type is expulsion type HV fuses. So this is it. This is an expulsion type HV fuse. So this is also not required as per syllabus, but I'm giving brief introduction about these fuses. So these fuses are used for the protection of feeders and transformers because of their low cost. So since these expulsion type HV fuses are of low cost, they are used for protection of feeders and transformers. The fuse link chamber is filled with boric acid. There will be a fuse link chamber. If you see in this image, this is the fuse tube. It is filled with boric acid. So whenever fault occurs, arc means whenever fault occurs, of course, arc is struck between the terminals of this fuse fusing element. Okay, of course, fusing element will immediately reach to its blowing melting point, and it just blows out and arc is struck. So under fault conditions, the arc heat will decompose the boric acid into water vapors. So boric acid will be decomposed into water vapors. These water vapors blast deionizes the arc path and prevent the arc reignition after a natural current zero. Okay, so what is natural current zero? What is reignition? Preventing arc reignition, I will discuss in this unit only later on. Okay, so only the thing that we have to remember is that there will be a fuse link chamber, that is fuse tube here, and whenever arc is struck here under fault condition, that arc will be deionized by the boric acid, which is vaporized into which decomposes into water vapors, and these water vapors will decompose the arc path, preventing arc to restrike. So boric acid expulsion power fuses are divided. They are further divided into refillable and replaceable fuses. So this is not required as per syllabus, but I have included to give some brief introduction. So this is liquid type, cartridge type, metal flat fuse. So applications of the fuses. So fuses can be used in the for wiring, electrical wiring at the houses. They can be used in the air conditioners, refrigerators, TVs, washing machines, etc. They can be used in laptops, mobile chargers, as well as in the automobiles.